Hello everyone, welcome to In 5 Minutes. In this video we are going to solve a sum that is based on circular convolution. We are going to use the basics of DFT and IDFT to calculate circular convolution. The question is, compute the DFT and FFT to determine the circular convolution of sequence that is x1 of n and x2 of n. So let us find out the circular convolution of sequences. The 4-point DFT of x1n is x1 of k, that is x1 of k is equal to W4, that is the twiddle factor matrix, into x1n, that will be the sequence. We know that the W4 is equivalent to this matrix. So finally we will calculate x1 of k, that is equal to this matrix multiplied to the x1 of n, that is the sequence 1, 2, 3, 1. When we will compute the multiplication, we finally get as 7 minus 2 minus j 1 2 plus j. Now similarly we will calculate x2 of k. x2 of k is equal to W4 matrix, that is this, multiplied by sequence matrix, that is x2 of n. We finally get the answer as 11 2 minus j 1 2 plus j. Now we have to use the property of circular convolution. The property of circular convolution is that x1 of n convoluted with x2 of n is equivalent to the DFT multiplication, that is x1 of k into x2 of k. We have calculated the x1 of k and x2 of k. So let us calculate the circular convolution. So y of k is equal to x1 of k into x2 of k, that is 7 minus 2 minus j 1 minus 2 plus j into 11 plus 2 minus j 1 2 plus j. Now we are going to multiply each and every term. So 7 into 11 gives us 77 minus 2 minus j into 2 minus j, that is minus 2 into 2, that gives us 4, that is minus 4, plus 2j minus 2j plus j square. J square is equivalent to 1, so finally it gives us minus 5. Similarly 1 and again the same minus 5. Now for calculating the circular convolution, that is y of n, which will be the final result, we have to calculate the IDFT of y of k. So according to the definition of IDFT, we have y of m is equal to 1 by n, that is the period, into wn star into x of n. So now the n is equal to 4, so we will write as 1 by 4 wn raised to star into x of n. But here we have calculated the y of k, so we will write here as y of k, that x of n is actually y of k. So now that is equal to the complex conjugate matrix of wn into y of k. So finally after multiplication, the final result is 68, 76, 88 and 76. All these coefficients divided by 4 will become 17, 19, 22 and 19. So the final result, that is y of m, is equivalent to 17, 19, 22, 19. Thank you.